Good day, everyone. My name is Kamil Dziedzic. I'm a technical specialist at Graitec, the chartered structural engineer based in Poland. I'm delighted to present to you today on behalf of Graitec and the Institution of Structural Engineers. This presentation will focus on the second generation of Eurocodes, specifically the challenges, the opportunities they bring to structural engineers. We will try to explore the key updates, the roadmaps, how the changes impact structural design, and what adjustment engineers will need to make in the day-to-day work. I look forward to sharing some insights and discussing how we can all adapt to these changes, hopefully for better, safer, easier design. If you have any question, feel free to ask at any time. Put them on a chat. I will try to answer them live during the stream, as well as during the Q&A session in the end. So thank you for joining me today, and let's now move to the topic. Thank you. Here is a quick agenda, what we will focus on. So starting with just brief introduction to what Eurocodes are, and maybe the importance in the structural design. Then the main topic, new Eurocodes, so-called new Eurocodes. So starting with overview of the second generation, the development process, the roadmap, and the most important, I believe, compliance, and what is expected from us in the upcoming years, because it's not a topic maybe for today or for tomorrow, but it's pretty close. Then a deeper dive into the key updates and changes in specific Eurocodes, focusing on how this revision impact structural design. I will, if it comes to the application, I will focus mostly on one of the codes as we are time limited. So I wanted to get this a little bit more detailed dive, but to make it detailed, I can only do it on some selected changes. We will wrap the session up with the Q&A session. So if you have any question, feel free to answer me. Before we begin, let me introduce our software that I mentioned before, Graitec Advanced Design. So as we explore the new generation of Eurocodes and their implications for structural design, it's important to highlight also structural design softwares such as Graitec Advanced Design, based at this time on first generation of Eurocodes, with the second generation to come. The software itself, it's a multi-material finite element method solution that allows engineers to design steel, concrete, timber, masonry, and soon to come also composite elements. Of course, in full compliance with the Eurocodes. Not only, also the other codes, but as for today, let's just focus on the Eurocodes. The software enables engineers to run linear, non-linear, modal, backlink, so different types of analysis, ensuring that all structural design meet the requirements for the safety, for performance, and so on. So as we discuss right now, the new Eurocodes for the advanced design are being prepared. So the software is being prepared to streamline these codes. Maybe I will tell a little more details about the development process in the end. So now jumping to the main topic. Eurocodes, a set of standards. I think they don't really require much introduction to us as European structural engineers. They are our day-to-day base for the design. At this point, when talking about the next edition of the standards, we can actually reflect on the goals that led to the introduction of the first edition. And first and foremost, answer the question of why a second edition was required or needed, and what changes it will bring to our design process. Were these intentions justified and was the goal achieved? To be discussed, of course. This is something that we'll try to answer, think about during the meeting, and I believe everyone will draw their own conclusions. It is obvious to us what the main goal was, namely the unification of methods, of the design approaches, the regulations related to the structural design across all of the European Union. Of course, this process took a long time. It was influenced heavily by legislations in individual member states. However, now from this perspective of many years, since we are actually talking about like 40, maybe even 50 years since Eurocodes appeared as a set of standards, or at least as idea of what they had to become. We can also see other advantages that to some extent there were arguments for introducing such unified regulations. The Eurocodes in the final form as we know them today distinguish several parts from 0 to 9. Of course, referring right now to the first generation. However, it not much change with the new codes. Typically, each part addresses a different scope, a different aspect of design, corresponding to usually to different type of material. However, together, starting from Eurocode 0, 1, so basis of the design, the actions, then followed with the dedicated design code. They create a cohesive set of standards which should able structural engineer to design any structure. The implementation process of the first generation of Eurocodes was long and consistent. The idea of creating such a set of harmonized codes dates back to like 70s, but the actual adoption across European Union took several decades. So the key milestone included like publication of individual parts of the code, starting with like concrete. This process did not conclude uniformly across all the countries. So in many cases, implementation was delayed. And even today, despite the former status, Eurocodes are not fully applied in everyday design practice. Many engineers still rely on like older national standards, which suggests that the first generation was not entirely successful. So this raises an important question: what caused these difficulties actually? Were they due to the complexity of the code, the scope, the lack of like sufficient implementation? It seems that these challenges were among the main motivations for developing the second generation of Eurocodes. So the goal is not only to update the technical knowledge, but also to simplify, to clarify the provision and expand the scope of the standards, simply to make them better suited to practical design needs. With the second generation, are we able to be more successful? It's too early to tell right now as we speak. We are only at the beginning of the implementation, but we can already examine the goals behind this implementation. and what are the actual changes being introduced. So why introducing the second generation of Eurocodes? I little bit answered this, but the second generation, like implementation of the second generation, the new Eurocodes was initiated soon after the first generation had finally been implemented to some point in many European countries, actually. This raised question, why update something so recently adopted? The key motivation was not to rewrite the Eurocodes, but to introduce kind of a major update, but significant enough to warrant the term second generation, the new Eurocodes. The intention was to improve clarity, usability, harmonization without starting from scratch. So use the first generation and redo them to what they initially was meant to be. So there were some limitations with the implementation of first generation that motivated the second generation. First, delayed and inconsistent implementation across member states. Not enough harmonization, for example. So the national annexes, lots of them, which allowed significant deviations from the core standard, and complexity, and very poor usability at the beginning, at least, making the codes difficult to apply in like daily practice compared usually to all the national standards. So these issues led to a loss of confidence in the system in general, both among the institution, the practicing engineers, and so on. The second generation aims to address these flaws by reducing first national variations, simplifying the content, and improving overall practicality. Did they succeed? Let's see in a while. The full impact actually remains to be seen, as we are in the beginning. The motivations are clear, to make the Eurocodes more effective, safer, user-friendly, more harmonized. So each a kind of a major update, actually. As mentioned before, the second generation of Eurocodes was introduced to improve clarity. The path of achieving these goals is structured with a clear roadmap, let's say, starting in 2016 with initial development phase moving towards completion in September 2027. So this process is, as you can tell, almost actually more than a decade. So it's not something relatively new. So again, comparing to the first generation of Eurocodes, the process is pretty time consuming, maybe not as much as the first generation. So here is the difference. But this process from start to finish was also including like public consultation, drafts, then final approval, of course, and what we are waiting for, official publication of all of the codes. Some of them are already published. However, it's important to mention this public consultation and the first draws, because the motivation that was behind the implementation of new Eurocodes is somehow related to this consultation where feedback from the engineers and stakeholders were gathered. Maybe some of you had actually delivered some feedback, as any European citizen could. And public consultation were fully open, and the first draws could be read, seen by anybody. So once approved, the Eurocodes are officially published. The process, of course, as usual, continues with local implementation. So here is also some risk if the second generation will repeat the problems that we had with implementation, local implementation, the problem with adapting the codes to meet the national needs, to standards, national standards. Can they remain harmonized after this? Can they remain practical? We will see. This chart that I took from committee website shows the roadmap of the new Eurocodes with the key dates. So it's marked the date for the formal votes on each part. So the closing, the finishing, with the project, the draft being finished of each part of Eurocode. As you can see, the process has been ongoing for several years now. We are getting closer, of course, to the finish. However, as you can see, while a lot has been done, the most crucial parts of the Eurocodes are still yet to be delivered. And by crucial, I mean Eurocode 0, Eurocode 1, so like basis of the design, like action of structures. So even though we have already Eurocode 2, 3, 6 for the design, we are not yet fully compliant to use the new Eurocodes as a set of standards for the design. How about the parts? What actually changed? Because on the previous screen, on the previous slide, you could see that the numbering, the naming didn't much change. So the core structure maintained, of course, as the idea was to not create a new codes, but to deliver a major update. So the numbering, the naming remains largely unchanged. Of course, not for the parts of the Eurocodes. So like Eurocode 3 remains design of steel structure, but there are many different parts and sometimes also new parts of this Eurocode. Of course, it comes to naming and numbering, but it's also important to what have changed inside. So what's new, what's changed, how the methods for the design change. The update brings a greater emphasis on also new materials, on climate change, on robustness. So there are also some new codes, so-called Eurocode 10, Eurocode 11, that will be, in addition to the current ones, will be the new parts. But with the second generation of Eurocodes, also a new approach has been introduced. In addition to what we've seen just now, the main standards, to addition to the main standards, we now have also technical specifications and technical reports. So specifications are and reports are published by committee, and the specifications are meant to provide additional technical specifications for example, like emerging materials like FRP, so fiber reinforced polymers, which aren't fully included in the Eurocodes but are increasingly used in modern construction. TRs, so the technical reports, on the other hand, are detailed documents, detailed reports offering in-depth explanation and recommendation on specific design issues. So not like fully on scope of like new material, new approach, but focusing on singular method to allow you for a more detailed approach, or sometimes more simplified approach actually. They are not normative. So this is more like a guidebook for a structural engineers to use. This way uh, that of providing this new technical reports, technical specifications, instead of using annexes, additional annexes, because the annexes are still there, but including so many corrections and external annexes, makes it easier to react to the changing market of structural design. And now let's jump to what's most important, so the compliance of new codes. The biggest raised question, should I use or can I use? When should I use or can I mix some new codes with the old codes? So there are many questions, all to be answered actually with the roadmap, how it's how the transition is going. However, mm, starting with the main one, should I use the new ones or stick to the old ones? In a sense, both are valid until the withdrawal. So the codes that been already published, the new ones are, of course, valid. So you can use both old and new ones until the March of 2028, when the old ones will be fully replaced, meaning uh, the old ones will not be valid anymore. However, as we've seen, at this moment, we don't have every new part of the second generation published. So can I mix the ones that are already updated with the old ones? It actually depends upon the country. So each European country, for example, from my perspective, in Poland, it's not allowed to mix the first generation with the second generation. However, in UK it's allowed, but to be, um, you know, approach with caution. So for both of these main questions, it's generally not recommended. So you should at this moment stick to the old codes. But if you want to use the new ones, try not to mix them with the old ones. So I understand that you cannot fully use the new ones as there is no action on structure, there is no basis of design, but there are the drafts, there are the projects of this code. So if it's so necessary to use the new ones, I would recommend to stick to a set of the second generation. I would not recommend to use the new ones because even though some are published, there are plenty of fixes being delivered right now. So taking, for example, Eurocode 3, each part been already fixed for like several times, 5 to 7 to 10 new fixes, with some of the parts being actually declined and taken back to the project phase as some severe mistakes were found. So let's think about the goals right now before even looking into the details. What changed? Let's discuss the goals and how they fulfilled. So increase the harmonization. I would say yes, the one of the primary motivation that was the harmonization uh, largely been achieved as the new Eurocodes provide more unified set of rules. What's important, they reduce national discrepancies. So there are less values delivered by national annexes. So it probably will make it easier to uh, facilitate a cross-border designing, let's say. Clarity and user friendliness. It was another motivation, another goal to achieve the idea of developing the second generation of Eurocode. It was to be easier to apply in the practice. However, despite the intention to simplify the Eurocodes, still contain high level of complexity, um, particularly regarding like partial factors, load combinations, and so on. Uh, in some areas, they are clearer, but are still considered, the Eurocodes are still considered a complex for routine engineering work. So for like small practices, less specialized engineers, it will be still difficult. And it's important to mention that in terms of volumes, on volume, the number of pages and so on, the Eurocodes has actually increased, sometimes even twice. And Eurocode 2 is a good example of this. So another thing to keep the codes up to date. Of course, it's easy to be fulfilled. Any update would be keeping the codes to date. Are they technically better? Yeah, in some way they are more advanced, incorporating the latest research materials. For example, they now account for climate change impacts, new advanced materials like FRP or structural grass. So it makes the codes more future-proof. So in a long term, it's somehow perspective as we allow for more methods, for more structures to be designed in compliance with Eurocodes. In short term, of course, it's pretty challenging as it's in a way even maybe user friendliness as less user friendly, sorry, as it's delivering new knowledge, extended knowledge, and the volume is increasing. So let's now take a look at selected changes and impacted areas. Due to the limited time, we'll focus today on EC2 only. Hopefully, we can meet for more detailed trainings in upcoming months. It's like a year or two when we can still easily prepare. So until now, stick to the old codes and use this period to prepare ourselves for the upcoming changes. So the second generation of Eurocode 2 concrete design has significantly increased in length with dimension compared to the previous version with almost 500 pages now, compared to like 300 before. And I'm accounting it for the first and the second part. So the general rules and the fire design. The total number of pages has grown due to the added details, the expanded provisions reflecting the incorporation of new materials, design methods, consideration of modern construction practices. Uh, this increase in volume presents a challenge, as mentioned, as it requires engineers to familiarize themselves with more complex, detailed informations. Uh, the larger scope and additional complexity mean that proper training, deeper understanding of the codes will be essential for successful implementation. Uh, these are some the key changes introduced in Eurocode 2, as you can see, for the design of concrete structures. For example, there are updated provisions of concrete strength classes for reinforcement as well, uh, which simply reflects the latest material research. The rules for structural fire design have been improved to enhance fire resistance, and now we have more detailed guidance, for example, on durability, to address corrosion risk in aggressive environments and so on. Additionally, there are simplified design methods for beams, slabs, making the design process more efficient. Let's now move on to one of the examples. We won't have time, of course, to discuss all of the changes, so I selected one area of concrete design, Eurocode 2, that will allow us to demonstrate how these changes are structured and what the scope is, especially considering that at first glance they may often appear to be merely cosmetics. And indeed, from a practical perspective, this is sometimes the case because our workflow won't change significantly as the designer receives still a set of formulas, guidelines to follow. However, from theoretical standpoint, the changes are often quite different from what we were used to, which may lead to potential pitfalls in understanding, especially when we try to compare them directly with the previous edition one-to-one. So what we are looking here is the most basic formula for punching shear stress. So at first glance, again, we can clearly see maybe a little cosmetic changes, particularly in terminology, but not only that. The key difference is that we no longer base the design on the punching force, but rather the punching shear stress. These subtle changes in the naming of the control perimeter aren't actually random. They reflect more modern approach, which itself is based, of course, on a substantial body of research. What we as designers receive in the end are the resulting formulas derived from the research, of course. Let's take a closer look at the new edition of Eurocode that expands the scope of the provisions, finally addressing some situations that we've previously tried to handle in various ways. In past, we've often referred to other standards, at least I did, that had some correlations with Eurocode, but now we can see an extension of scope to include punching at the wall edges and corners and the wall openings, which was somehow covered, and the supports with large dimensions. So not all of the perimeter is effective anymore. Importantly, the extent of the control perimeter has also changed. We were used to a distance of 2 effective depths of a slab. Now this distance is reduced to just half of that value of the depth. Again, this does not come out of nowhere, of course, as mentioned earlier. It stems from a revised design approach. The design is no longer based on the traditional Schmidt truss analogy, so the assumed distribution and inclination of the compressive struts are now different. When it comes to the punching shear stress, resistance of concrete, without reinforcement, the formula might initially again appear similar in structure to the one from the previous edition. However, it actually differs significantly. Most notably, it introduces a new coefficient that depends on the shape of the control perimeter, specifically the relationship between the loaded area and the control perimeter, where we check the punching resistance both with or without reinforcement. This means we will observe substantial differences depending on the specific case being analyzed, whether it's a wall end, corner, an interior column, or this very large support. For the latter, we now account for a reduction in the effective length of the control perimeter. In the new Eurocode 2, the punching shear resistance of slabs with shear reinforcement is calculated using a more detailed performance-based formula. The contribution of the reinforcement is expressed through the shear reinforcement ratio and the coefficient eta s, which depends on the geometry, the reinforcement layout, this new punching enhancement factor that we've been talking just now, and also limiting this reinforcement ratio with this coefficient eta s is to ensure ductile behavior. The code also introduced clear definition for the effective perimeter and the radial spacing of shear reinforcement, improving clarity, but most notably keeping the consistency in the design. So from the resistance of concrete to resistance with reinforcement and so on. So let's now take a look at one of the simplest possible examples. It will allow us in the most straightforward way to observe the impact of these changes, specifically in the terms of how the structural system behaves, how the punching resistance is utilized, what is the work ratio, and so on. We are dealing with the simple case, internal column punching through a slab of constant thickness. At the very beginning, we won't notice any major changes because despite the new approach, the fundamental mechanism remains familiar. It hasn't changed in essence. The change is primarily in the calculation method. Of course, this is still of interest to us that we look at the effective depth of a slab, the punching shear force, the amount of the longitudinal reinforcement, which partially enhances the punching resistance of the slab without the dedicated punching shear reinforcement. However, as we move forward, we begin to see the fundamental difference in the extent of the control perimeter used for the punching shear verification. Most notably, we can observe that the control perimeter is only slightly larger than the perimeter of the loaded area. This, of course, leads to significantly higher shear stresses, much higher than the levels we were used to in the first edition of the Eurocode. This doesn't necessarily mean that the punching shear utilization at the control perimeter is excessively high, because we are now relying on a completely different design approach than the traditional strat model. What we observe here is that the concrete punching resistance also increases under this new method. In this case, it is limited by the maximum allowable value, and we reach a concrete punching resistance of around 2 megapascals. Nevertheless, this is still not sufficient to omit the design of punching shear reinforcement, since the concrete capacity is exceeded in that case. Let's take a step back for a moment to the previous edition of Eurocode, or rather to the method introduced by that Eurocode. Please note that in this simple example, the same example, we are using the terminology from the new edition in order to directly compare the parameters between both versions. So the control perimeter, which previously referred to UI, is now as a B0 at the distance of 2D. What we clearly see is that this perimeter is significantly larger, which naturally results in lower shear stresses. And for the sake of this comparison, I'm assuming a uniform shear stress distribution along the length of that perimeter. Using the familiar formulas, familiar to us from the previous edition, we can now calculate the concrete punching shear resistance along the control perimeter. What we notice, however, is the absence of any influence from the shape or length of the control perimeter on the concrete's resistance. Of course, the reinforcement, slab depth, the concrete strength class all play role, but the actual distribution of shear stress along the control perimeter does not necessarily affect the resistance itself. And when comparing these two methods, we can now conclude that what initially seemed like a more conservative approach actually results in the case of Eurocode 2 in lower utilization of the concrete punching shear resistance. In addition to the factors we have already discussed, an important role is also played by the partial safety factor. For punching shear, it is now set to 1.4 instead of 1.5 value typically used for the concrete. Some countries will experience this change more significantly than others, since the gamma C value was previously governed by the national annex and differed from 1.5. Naturally, this is not everything. These aren't all the changes, all the areas where we expect changes concerning punching shear resistance. In some cases, the differences may be so subtle that the terminology or general approach appears unchanged, yet the impact is still noticeable. One example is the parameters listed in the table here. Previously, for example, SW represented the total shear reinforcement along the full perimeter. Now, because we approach punching reinforcement from the other end, starting by determining the required reinforcement ratio, which is then distributed radially and tangentially, and this ASW refers to just a single shear bar walking in shear. Similarly, the former VRD max, or like maximum capacity, was related to the compressive capacity of the strut itself, of the compression concrete strut. Sorry, the compressed concrete strut. In the new approach, it is no longer represented as the same thing. It now defines the maximum allowable shear stress tied to the capacity of a concrete section with reinforcement. So it's the maximum stress that could be reached on the U1 control perimeter, not U0 as before. This limitation had already been introduced actually in the amendment A1 from 2015 to the first Eurocode edition, although not everyone may have been aware of it. Another example is the punching shear capacity of a reinforced concrete section. The new parameters eta C, eta S allow us to control the contribution of concrete and reinforcement separately, something we didn't have previously. These values used to be constant, but now each case must be treated individually. So each case becomes a very specific one. At this point, I'd also like to mention how Graitec, as a software provider working with Eurocode, is approaching this transition, because as we can see from this example, the changes are often far from cosmetic. While some areas are more or less affected, we are already actively working on the implementation of the new Eurocodes. In practice, this involves establishing 10 technical committees, each dedicated to a key part of Eurocode second generation. These committees bring together of a total 25 structural engineers, construction specialists, structural designers, among many European countries. Their task is to develop detailed specifications of the changes and new requirements. What's particularly important, considering the current lack of a real-world examples or textbooks based on the new edition, is that we are also working on comprehensive set of calculation examples. This will support testing, the verification of the new algorithms implemented by our development team in the upcoming version of our software, Advanced Design. Moreover, this knowledge will serve as a foundation for training, both internally sessions for our engineers and also external ones for our customers. Implementation in software is one thing, of course, but understanding why we obtain a given result and where it comes from is just as important. Currently, since we work in an annual release cycle with a major version and a little smaller media update that often includes just fixes, sometimes new features, our plan is to roll out support for the new Eurocodes primarily next year. This will align with the availability of the standards, even if the application is not yet mandatory. Uh, by the time of the official release, we aim to have implemented all essential components. Of course, this period also coincides with the national committees. So, from the um, European Committee, moving to the national committees to um, finalize their work, completing translations, national annexes, and so on. The next version of our software will also allow for the integration of these national adjustments. After all, one of the core ideas behind the second generation of Eurocode is to minimize the number of nationally determined parameters. So I'd like to thank you for participating in today's session. This has been more of an introduction, a first step in familiarizing ourselves with the upcoming changes, but it is also a great moment to begin the process of preparing for the transition. Looking at the timeline, we still have about 2 to 3 years ahead of us and likely an additional transition period, probably and hopefully. These next 3 years will be crucial, however, in getting ready for the shift to the new codes. I hope we will have many more opportunities to meet again uh, during dedicated training sessions, technical workshop, and so on. So I encourage you to stay tuned for updates and future announcements. Once again, thank you for your attention. If you have any questions, please feel free to leave them in a chat. Yes, so there have been some questions during the presentations that I tried to answer them live. So if you're interested, you can go to the Q&A, see the answered questions. If you have any more, you can still put them on the Q&A. Let me answer them live. That the new that appears, I won't provide the text input anymore. So starting with Alex, yes, you are fully right that it's not very user friendly, and considering this new generation, as we discussed in the webinar, the user friendliness is merely on the same point as it was for the first generation. Even though it was one of the major motivations, unfortunately, we will need to keep to what we were used to with the first generation. Again, the harmonization is slightly better, especially with the national dependencies, but the user friendliness, it's on the same level. A question from Tom, will advanced design have built-in comparative tool? Maybe not really a comparative, however, we tend to support the first edition of Eurocode. Of course, alongside with the new versions, this software allows you to run the same structure verifications with the selected code, so you can switch between them to compare the results and to check the compliance of the structure with both editions. So not really matter if we design it with the first edition or second edition, you can always have them in parallel to switch, to check, to verify. Is there a list of TRs docs to be published? Yes, there is. So if you go to the, and maybe I will try to post a link in the meantime. You can go to the European Committee website with the second edition of the Eurocodes. There's a list of documents to be published, so including both the core standards, the specifications, and also the reports. This is a pretty nice tool because it allows for quick implementation of some addition methods. Usually the TRs are related to the core standards, so they are related with EC2, EC3, and they give the designer some simplified or more advanced, in some cases, methods to solving just a one technical aspect, one technical issue. While the TRs are more general ones, so they are not only about a method, but about a full scope of some technical aspects. Yeah, so this session was a introductory one, more about the roadmaps, more about the compliance of the new codes. It's for some yet too early to start with the detailed sessions, but yes, both the organization and both Graitec, I believe, are having in mind to host some more detailed sessions. So it's yet to come, but for sure we will host some. This is the plan to nurture the customers with the idea of change of this new Eurocodes. So about the recommendations to get ahead of these changes, it's pretty difficult as there are no yet worked examples, as we discussed, no real guidebooks based on the second edition. However, all of the codes already, the ones that have been published or the ones that haven't yet been published, usually have a draft version that is available. And so the idea would be basically to see the changes firsthand. Again, as Graitec, we, even though we are a software company, we have this in mind to deliver trainings, to deliver sessions, to introduce engineers to not only the general picture of changes, but also to have it, very detailed. And the committees that we have hosted, the idea of these committees, it's almost 30 people working day to day as we speak on the examples, on preparing specifications of the changes. So this will be a base for running such trainings. Where I can find to read the second gen codes, of course, it's upon the country committees to deliver them widely to structural engineers. Generally, what you can have a look on publicly is the drafts, so you can check the committee's website. There are also some insightful presentations done in 2020, 2023 on a committee meeting, for a committee meeting, that introduces us to changes of each part of Eurocode. So my advice is first to browse through the European Committee website dedicated to the Eurocodes. So the TRs are being released in the same manner as it's for the core standards. Same for the TIAs. So there is a full release cycle, starting with draft, the final vote, approval, and publication. So the TIAs and TS that are already being in work, some of them are already published. Even though we have some core codes that are still under work, specifications are already published, and they will be accessed the same way as the Eurocode. So this is a tricky question about the project starting and ending throughout the changes. So the recommendation is to carry on with the project with the current edition of the Eurocodes. However, if it's about to end many years, at least the construction will be carried many years after the withdrawal of the first edition. More wise or most wise would be to follow up with both editions actually, but I know it's pretty difficult. Um, Singular cases, I believe that will have this period of more than 5 years working on a project, but for sure there are some. So right now I would still, of course, carry them with the first edition of the Eurocode, and it somehow should be stated within the contract. I believe it's also a thing to think about signing off a contract for the design to consider the addition of the codes that the project should be supported with. Of course, please remember that some codes have or are more impacted by the changes than other. So the EC2 that I have chosen for this example is actually one of the most impacted codes, even considering such simple thing as the number of pages grew almost doubled in volume. While comparing to some other codes, the changes are not so great. There is more harmonization, but the general methods stays. So the idea is this. But EC2, unfortunately, is very much impacted. So for the punching shear, as it was the example, the new method, which is now experiment-based method, is more closer to the USA approach than it was before with this first edition of Eurocode that was based on the Schmidt-Truss method. So the idea of this new edition was also, to follow up with some more modern uh, trends also on the experiment side. However, as you know, the stud rays are supported not fully by the Eurocode, even though uh, even though these documents they are based on somehow relate to the Eurocode. In European countries, it's usually based on the European technical documents related to the products. So they will have some separate rules, I believe, again with the new version of the Eurocode. So thank you again for joining me today. If you will have any more questions, you can reach me at Graitec anytime, or reaching our support teams. Feel free to ask some questions. And hopefully see you on the next sessions related to the Eurocodes. Thank you and bye.